So what we're doing is we are looking at the internal structure of dolphin teeth, because similar to trees, which you see rings over time, we can actually look at those and study the chemistry of those layers and see if they have picked up heavy metals and other elements from the environment. So I think the first steps is, of course, we have to cut the teeth in half and prepare them, polish them, and then we take them to equipment here in the Department of Chemistry, a laser ablation spectrometer, and we then measure the levels of heavy metals in those layers. And because we know how old those animals were and when they died, we can actually trace back in time which years those layers correspond to. So this is a very powerful method that we're using. So in this small study, we're looking at dolphins that are from New Zealand, from a region around Auckland, and we are looking as well through my colleagues in Australia, in South Australia, in Adelaide more precisely, from that region, because it's one of the regions in the world that there's heavy levels of pollution because of lead smelting and other mining in those areas, which are discharged into the waters in the harbour where those animals are living. So in New Zealand we don't have as many mines active, especially for those metals, but the situation might change in the near future. So it's really important that we have baseline levels measured now, so if we have mining implemented in more large scale, we can actually compare that information.